negative thoughts. If you can practice that, that's why I made you think more positive thoughts. And then I made you think only about one negative thought. So in general, when you maximize your positive thoughts and minimize negative thoughts, then you will be achieving great success in life. A lot of our Indian spiritual gurus also say something similar, right? And when I posted it on LinkedIn network, I think I had over 200 people who started looking at it and commenting and things like that. That's also called in our Indian Vedic literature. Somewhere we talk about controlling your mind, right? How do you spell control? Is it one L or two L's? One anukunta kada? Controlling your mind. That's what it's called. Mind can do wonders, right? So when in distress, always think a lot of positive thoughts. Okay. Can a thought control an action? Scientists have proved. Students, I think you probably would have read about it, right? Recently, there was a study done where a paraplegic person, paraplegic ante wheelchair bound, and they have this paralysis, right? They can't move their arms and limbs and things like that, right? So this lady was hooked up to a computer, the brain, and then it was hooked up through the wires and all that to a computer, robotic computer. And then there was an arm, right? So what they did, the experiment was, in her mind, the thought was she was moving her arm to reach for a coffee mug, which was at a distance. That was the thought in the mind. Remember, she is paraplegic. She can't really move her arms and limbs, right? Guess what happened because of the thought? The arm moved and she was able to get the coffee cup at a distance, not like too far away. So they just proved that really a thought can make a difference. Okay, I will now jump into our lecture. Questions, comments? So last week we talked about implementation, right? Different types of implementation issues that we have to consider, not short of coding. When we talked about that implementation chapter, we talked about all the issues like layout of the physical servers, non-functional requirements, replication of the servers, redundancy, availability, all of those things, right? So today we'll talk about testing. Okay. What is software testing? Again, it's a pretty, I would call this an easy chapter, but an important chapter, right? Testing is a very, very important facet of software development, right? How many of you do test your code thoroughly? You've written programs, right? I assume that when in your programming language classes, the instructor would have shared with you how do you go about developing the testing, right? And conducting the testing. And testing is done at various levels, right? We talk about in programming, you probably would have talked about unit testing, module testing, system testing, different layers of abstractions of testing. So we'll try to formalize some of those things here. And then the reason why I wanted to kind of cover this topic as well is in the midterm next week, I would make you write some test cases For the problem that you'll be working on, you will also be writing some test cases. Okay, and of course your final project will also have test cases. Okay. Okay, let me put it in presentation mode here. Check out. I'm getting into the lecture, not waiting for anyone else. Huh? Do you want me to record this meeting?
Sir, we are also recording. No problem.
Okay. Oh, you're recording. Okay, great. Then you can share it with them.
So you can see that through that ID we are actually recording.
Oh, I see. Okay, perfect. Perfect. So what does testing mean? Testing is intended to show the program does what it is intended to do. And that means we are testing for functionality. And in the process of testing, if we find any defects, then we try to fix the defects. Okay. When you test, when you're testing your software, you are using artificial data. I don't like the term artificial data. Call it test data. Okay. There's nothing artificial about data there. It's not real data. That's why I think they call it artificial, but just call it test data. Okay. Then of course you know what the expected behavior is. You compare the test results with the expected behavior. And based on that, you will know whether there are errors or there are no errors. Okay. So there is this entire field called verification and validation. So testing is like it fits under the umbrella of verification and validation. Okay. I'll put a question on what verification and validation means. You can go research what that means. Okay. Now, what is the goal of testing? Obviously, you want to make sure ultimately it meets the customer requirements. Remember, we start with a problem statement, right? And then we've come up with requirements. So eventually you're testing to make sure all the requirements are met. Okay. So there's pretty much a one-to-one or one-to-many mapping between a requirement and the test cases. I don't know if I have the document on my laptop or not. One day I'll share it with you. One time I was doing a project in Cisco. I was managing a project. I went into a hostile environment there where our business side of the team, people warned me, Pratap, she is a tough nut to crack. She is going to make developers' life miserable every single time. And that was a very crucial piece of software. The software computes the sales commissions for the salespeople. Obviously, wherever there is a financial type of application, you have to ensure the integrity, accuracy of the results. So I told her, don't worry, I will handle her case, right? So I immediately said, you know what, to handle this particular manager, the business side manager, I need to be more methodical. So we had all the use cases. We created a test plan, a complete, like I had a 100-page test document, all about 100 use cases, test cases mapped based on use cases, right? I made her review all those test cases, and there's a template that we follow. What is the input to the test case? What is the output? And what is the activities that that particular test case has to do? So by doing all of those things, what it ensured is that there are no last minute surprises from that lady, because she signs off on everything, right? And then, true to her nature, Tirmal Rao garu vacharu.
Sir,
Good morning,
good
Tirmal
morning,
Rao
sir. Sorry for the delay, sir.
No problem, Andi, no problem. So, true to her nature, a day before we were supposed to go live, she raised a stink. Your system is not meeting my requirements. This requirement is not there, that is not there. I said, Hey, if I missed anything, I'll work 24 hours with my team to make it happen. But let's go back and see all the things that you signed off. So I showed her the requirement that she signed off at the beginning of the project. And I showed her the entire test plan document that she signed off. Then I said, show me what is it that you want which is missing in that document. So basically, I put her in a spot and she was looking at the document to figure out what is missing. So why am I sharing that story? Because whenever you're doing these things, there's a reason why we want to get a sign off of all the way from requirements, your use cases, your test cases, because there's always somebody who is the reality is there's always somebody who likes to see you fail. So that way they can say, I told you so. So it actually helps you professionally as well to follow some of these processes formally. Okay. Now, there's an interesting tidbit that we share whenever we talk about testing. Uh, how much time do you do testing? Can testing ever say that your program is 100% correct? It's a question to the students. Can testing ever say that your program is 100% complete, accurate, correct, whatever is the term that you want to use? You can either speak or put it in chat. Can testing ever say your program is 100%? Can you guarantee then testing cycle that your is 100% accurate and it works with no bugs? It's impossible
No,
to say
sir.
that. Yeah, you are absolutely right. It's no, right? It's impossible. It's actually it is a, I think if you, what we call it as there are some classifications of programs in automata theory. I think this falls under the undecidable problem, I think. Testing can never be complete. You can never say your program is 100% correct. You do as much testing as is humanly possible. Now, when you say humanly possible, what it means in real life is you allocate some amount of time to do the testing. The rule of thumb is one third of the development cycle could be allocated to testing. Okay, one third and 33%. 25 to 33% is the time that you typically use on a project to do the testing. Okay. Okay, great. Uh, when you're testing, other thing, I don't know if it comes in the slide or not. Let me put one slide here. And for welcome to Vijayanagaram students here. We are doing the module chapter on testing, which will be part of the test next Monday. Monday is your test, by the way. Remember, I gave this login. If you have a login password form, what kind of functional testing would you do here? What would be a test case here? Somebody raising their hand or in GEC or Vijayanagaram or anyone? What would be a test case here for login password? How would you test login? It's a silly question, right? You enter name. Yeah, somebody said whether the password and username are correct. So you enter name, enter password, right? See if it works. So your test file would say enter the following name and then enter the following password. It should say, okay, welcome to the program or welcome to the student information system, whatever the case may be, right? So when you enter name, typically how many characters you enter? When I say characters, it could be alphanumeric, right? Because in Cisco, for example, my username is pchillak1. That's my username. Okay. So typically how many characters? If it is like some organizations have it based on first name dot last name, right? Now, in India, our last names can be fairly long. So maybe who knows? Typically, it could be 25 to 40 characters, perhaps maximum. That's an overkill, right? Most of our usernames are what, 8 characters, 9 characters, right? And then how do you, and then password, right? So what kind of things you test in password? Number of characters, first of all, because we do not take small passwords now, right? Number of characters should have a combination of and small letters, uh, some numbers, and special characters, right? So these are all the various ways in which you test. Even for simple things such as this one, based on what I have written in the slide, how many test cases would be there? At least 10. If you take the combinations of these things, it will be at least 10 test cases. Okay. Uh, you get the idea, right? So you know what the functionality is and you know the requirement. Now, how do I know that password should have a combination of these things? Because somewhere in the requirements you would have stated passwords cannot be simple 1, 2, 3, 4, 5, 6 or something like that. It should have a combination of letters, alphabets, and special characters. That's why you test those things. Okay, that is whenever you talk about testing in general in these books, you're talking about functional testing because they're testing for functionality. That's why we call it functional testing. Now, can you imagine if I were to test in the following way? For login, what if I enter a 256 character string? Okay. Let's say for password, what if I enter a 1000 character string? Have you ever tested a login with 256 character string? Anyone in the class? Probably not, right? Same thing with 100 character string password. Actually, some of the apps, you test it out. Some of the thing that you log in, I won't say which sites and all that. You enter a 1000 character string and see what happens. The chances are probably the system will let you in. Okay. So what is this testing called? Can somebody give a name to this type of testing? Somebody is coming to the speaker. Or they went out to get some coffee. So what we call it, they are called, first of all, they are called non-functional testing. Because nobody in the functionality would use a 250 characters login name, right? Only stupid people might have something like that. Good morning, Tigar. Am I saying welcome to from, huh? Oh, no problem. Oh, okay. No problem. I thought you probably are traveling and you're in USA today. Okay. Oh, I see. Okay, no problem. We'll continue then. So this testing that we are talking about falls under the umbrella called non-functional testing. Because functionality, nobody would say, I want a 256 character login name. But in today's world, whenever you're developing systems, you should always do the non-functional testing too. One of the non-functional testing is called, this is security testing. The particular example that I'm taking, it falls under the umbrella of security testing. Now, why do we call it security testing? Because the way people, the hackers get into the system is precisely by means of sending very long strings to break your code. Okay. In your compiler classes, I believe you did a compiler class, right? You would have learned how all these things are put on a stack in your memory, correct? Whenever a procedure calls another procedure, there's something called a return pointer, right? How does the system know? Compiler builds these things on a stack in memory, and then as it executes the instructions, fetches them one by one, when it comes to a certain point, it knows what the return pointer is. Return pointer means where it branched off. So it will put the code back in at that point of time. So what the hackers do by inputting such long characters, they are probing your stack. Somewhere the hope is they will overwrite the stack, and in the process of overwriting the stack, they will put their own return pointer. So that way, when the program comes to that point, instead of returning to your code, it will return to their code. So there are a lot of tricks like that. When you take my security class, I'll show you how some of these things are done. But that falls under security testing, just as an aside. Okay, I'll now speed up a little bit because it's pretty easy chapter. Okay. So validation. Validation means what? You are expecting the system to perform correctly using a given set of test cases. So you're validating that it is doing what it is supposed to do. Okay. And the second part that you're doing is you're saying, hey, are there any defects? Okay. So the defects could be security defects. It could be other defects too. Okay. So to validate is to demonstrate that the system is meeting the customer requirements. Okay. Defect test. What is an example of defect testing? If it is an ATM machine that you're doing, and then let us say if customer you're testing deposits. Okay. So let us say here, example is, let me take a new slide here. Let's say you are doing an ATM And then the user first checks for balance. Her balance. Okay. Let's say it is $100. And then the user deposits money. Let's say $300. So your test case would then has to give the new balance equal to $400, right? So you wrote the ATM software. Now, if the new balance shows 4,000, then of course the bank guy who gave you the business would fire you immediately, right? So that is validating and then also verifying there are no defects. It's kind of like, I do not know if anyone of you experienced, it happened to me once when I was in India. I think the ATM machine was just coming, right, in those days. Uh, Generally, whenever I go to this Andhra Bank or State Bank, buy one of those things and get 25,000 rupees or something. So one, I got the money and then I just put them in my pocket. And my cousin who was with me said, "Have you counted your money? How many of you count money when you get money out of ATM machine?" I assume you count. Then I asked him, "Why do I need to count? I very rarely count even in USA." Then I said, no. In India, it is special case. So you always have to count because chances are you've probably gotten less money. So I believe there are a lot of cases where it gives you less money. It never gives you more money. I don't know if it has ever given you more money. That will be a great ATM machine to go to. So anyway, that is the verification and validation of testing. Okay. So how do we typically do that? So you have inputs, you have the system, you have output. Pretty straightforward, right? And then, and you know what the expected results are. If it matches the results, it's correct. If it doesn't match, that means there's something wrong. Okay. So here are formal definitions for V and V. Okay. What verification means? Are we building the product right? Okay. So that means the software should conform to its specification. I give a requirement, it should meet. Validation is, are we building the right product? Okay. Slight twist of words there, right? I can build a product right to a specification, but what if the specification was a bad specification? Imagine, who can, before I give more explanation on that. Sorry, I jumped a slide there. Who can add more clarity to those verification based on this and validation? It's a very big buzzword in industry. Right? Okay, that's a great example. That's a great example. That's a great example. Yeah, I will take that example. That's a good way of looking at it. So validation is more like it is like if the points have to be between 0 and 100, you are saying that as long as it's between 0 and 100, you validated the product. Look, okay. That is going to the values. Okay. Mhm. Mhm. Correct. Correct. That's true. I mean, I think you got. I think you said it right. If I want to abstract that a little bit more, what do we mean by if we are building the product right? Let's take a product example. Um, Product example. What could be an example of a product where we are verifying that what we build the right product? What if I take an example of a product in your same JNTU information system, course registration system, okay, for students. Let's take that as a product, software product, right? So who can give me an example of what is verification in that and what is validation in that? A course, JNTU Kakinada course registration system, meaning the students can go and register for courses online. Yeah. So what could be verification there and what is validation there? No, wait, you hold on to your thought. I want students to take a stab at it first. Yeah. Good morning, Aditya Engineering College. I see all of you there. Any students from GEC or Vijayanagaram who want to tell me what the verification is in the context building an online course registration system for the students? And with respect to that, what is validation? Tirumalogar, you can also take a stab at it from Vijayanagaram. Correct. What you said is correct. Okay. But I do want to tell the students, to me, whenever I see these terms verification, validation, I have to go back and look at the definitions. In practice, we really don't say verify, let's validate. We just go test. So there's no need to get hung up on what these terms are. Chances when I go have my tea or beer at the end of the class, I would forget what the definition is. But the basic idea there is, at a high level, are we building the right product means you are building the right product to meet a business need. Okay, that's number one. If the guy wants you to build a course registration system where the students can go register for courses, instead of building a course registration system, you build a payment system. I'm just giving you a contrast example, right? The guy wanted you to build a course registration system where students can go register for courses. Whereas you build a system where students can go and pay the fee, the student fee, registration fee, but not the actual enrollment of the courses. That is not the right product, right? The university asks you to build a product where you should go register for courses, whereas you build a product where students will go to the system, but instead of registering for courses, all you allowed them to do is pay for. Okay, then it's not the right product. Okay, so right product, and within the right product, the accuracy of the results is important. So verification is testing the accuracy of the results, completeness and accuracy of the results. Validation is ensuring that, hey, we said we'll build a product to register for the courses. Have we done that? Okay. So verification is very specific to the outcomes. Validation tends to be more from a business objective viewpoint, whereas verification is the technical aspect of it. Okay. I did. Okay. Oh, welcome. No, no, no. You are being too kind to me. Believe me, I'm telling you, once I go out of the class, you come back and ask me again, I would have forgotten what I told you. Okay. Okay. So, what is the goal? Goal is really to establish confidence, right? The system fits the purpose. Okay. And then it meets the user's expectations. And then most of these products are built in the industry based on some push from marketing guys. So you get the marketing stakeholders. It has to meet their needs. So all of these things uh, become important when you do verification and validation. One thing I want to bring your attention to is the last bullet here. From a marketing viewpoint, if you see, getting a product to market early may be more important than finding defects in the program. That's a very interesting statement, right? We actually used to joke 15, 20 years ago in the mid 90s when I used to teach in different companies where I got invited as a UC Berkeley faculty. We used to joke, Microsoft never tested software. Who are the testers for Microsoft? The users who bought the software are the testers. That used to be a joke, right? Murthy garu and Thirumal Raghav, we are like a little bit older than you are. We know those jokes. Microsoft products never really worked well. The first release. If you are smart, you'll never buy version 1.0 of Microsoft, right? You always buy version 5.0 because the users use it, they report a lot of bugs. Microsoft keeps refining them, and then ultimately they get it right. But you should take it as a joke. Uh, the reason is Microsoft has a very strong testing team, at least now. They've improved a lot, right? They are fairly robust. Testing, of course, even the programming practices have changed now, right? Uh, in my days, testing was like a waterfall life cycle model. Let me mute Aditya, idle. Okay. Now testing in today's world, testing is integrated in the development life cycle. Testing is done as part and parcel of your agile development methodology. Okay. You cache them as you keep developing. Okay. But in the good old days, testing always used to be an activity which was done later after all the development and all is done. But now it's much better. Okay. Okay. There used to be, I don't know how much we do it today, quite honestly. There used to be a thing called inspections. Okay. There's a very famous guy. I want students to check this out. Let me see if I can put it here. Check out Tom Gilb, former IBM person. He gave a methodology called Tom Gilb's inspection methodology. What inspection is really is, you're not doing the actual testing where you're inputting values and then looking at the output and all that. This is a static analysis. You take the system representation and then you apply this inspections methodology to see whether your system is meeting the requirements or not. I used to teach a course on inspections in Hewlett Packard. That was almost, 27 years ago. Okay. I don't remember any of it now. So don't ask me what Tom Gilb's inspection methodology is. I completely forgot. But it was one of the standard, very world-renowned inspection methodologies. Okay, I don't know where it fits. Maybe Thirumal Rao garu might know more because he's an active researcher in software engineering. Let me unmute you, Andy. Chappan
Sir,
Thirumal.
a small question from my side, sir. Verification, how it varies from the testing part. People say program verification is also static analysis.
So what happens is the 1 second. Let me mute you here. Program verification you're talking about, right? So whenever we talk about program verification and static verification and all that, you're doing some kind of a formal specification. There's this entire thing called programming based on formal specifications. What we do is think of it as kind of almost like a mathematical analysis, right? You give what are known as preconditions to a program. Okay. I used to use a language called type theory. There's a mathematical theory called type theory. I actually published a paper on that once long time ago, where we specify formally in a certain language, hey, here are the prerequisites before you enter the program. And when you come out of the program, this is the post condition, precondition, post condition, right? Without really executing the program, I can analyze that formally. That is that static verification. There is no execution of code. Okay. So when you do inspections, as you can see here where the testing is fitting in here, you can test all the things, right? You can use the requirement spec, software architecture, design. At every stage of the cycle in your software development, you can inspect or test. Inspect meaning you're doing like a design analysis. For example, when we do the security class, we talk about analyzing the architecture, right? So how are you analyzing the architecture? I mean, there are tools which allow you to analyze the architecture, but if you are doing it on a piece of paper, we analyze the architecture from security objectives viewpoint. Remember in one of the last classes, I don't know if you were there or not, Thirumal Rao garu, I said whenever we are doing a secure product development, one of the important things that we capture in the requirements is what are the security objectives for the stakeholder, right? And they're the classic CIA model, confidentiality, integrity, and availability. Okay. Those are three standard things, but there are other security objectives too. I list about 8 or 9 of them. So depending on which of the objectives are relevant to the application domain, I look at the architecture to see if those objectives are met or not. Okay. I may not be running it through a program, but I can still analyze it from that viewpoint. Same thing with database schemas. When I look at database schemas, one of the things that we can inspect is, students, you took the database class, right? You probably know normal forms, right? In database schema. The normal forms are what? 1NF, second normal form, third normal form, and so on, right? You have boys called normal form, right? There's even a fifth normal form. I forget what the fifth normal form definition is, but there is a fifth normal form and so on. Most of these things are completely esoteric. In today's world, they could be classified as useless research. I mean, I wouldn't call the people who did useless. They are database pioneers. When I was doing my database classes, it was important for us to know all these normal forms. What big data has done is they said, let's not normalize anything. Let's put everything in one big table. Okay. But inspect schemas, typically, I look at these things, whether the database schema is in third normal form or not. It's very important for me to have a database in third normal form. Okay. If you do your modeling correct, your schema will be in third normal form. What does third normal form basically means? What it means, what it tells me is I would not have insert and delete anomalies. That is what I'm inspecting the design for, right? When we're doing a database design, correct. You're right. But ultimately, what you do as part of those things is you're looking for insert and delete anomalies. And yeah, insert, delete, and update. Correct. So you're basically inspecting your schemas for those things. Okay. Okay. So Tirumala got to your point here. See this. The architecture or the code even before actually architecture basically, because you have not implemented in the code yet, right? Okay. And then you can do it for requirement design. Now, when it is not code, when you are doing these things, when inspecting, what is the quality of inspections? What can you observe about the quality of inspections? Do you think the quality of inspections would be very high every single time? Not necessarily, right? It really depends on who is doing the inspection, right? It's kind of like, I remember once we invited a well-known speaker from Tektronix. He was the inventor of a technique called CRC cards. Text box, just 1 second. Insert. Let me insert a slide here. He invented a technique called CRC cards. Has anyone heard about CRC methodology, CRC cards? Oriented programming or any of those classes. So CRC card stands for classes, this responsibilities, I think the other C stands for collaborators. This is like the beginning of object-oriented technology paradigm in the mid-80s. Okay, there were no formal methods. There was no UML. There's only a Grady-Booch method. Okay, CRC cards was it's like a 4x6 index cards. You take a 4x6 index cards. Given any problem domain, how do you analyze and how do you identify all the classes? You take 4x6 index cards. You take about 4 to 6 senior members, okay, and brainstorm. Okay, what are the potential classes? Imagine like Murtigaru and all, they have some plans for building an enterprise-wide information system for JNTUK Kakinada. How do you think he would do? He was asking me, hey, Pratap Garu, can you join my team? Okay, like that he will put together about 6 or 8 of us, different domains, and we'll probably sit in a nice room with lunch and dinner and all that stuff. And then we'll brainstorm. We'll say, what are the potential classes? What are the potential subsystems? That's how we identify our design. Okay. Now that is brainstorming. Now, what is the problem? Why am I saying this one related to inspections, right? Uh, if the people that Murthy garu has put together, they are not experts in this domain, do you think the brainstorming would be effective? No, it won't be, because the brain of people who are intellectually capable of doing that, right? If the competency is not there, brainstorming also the results would be equally bad. అది తెలుగు సామెత ఏదో ఉంది, ఏంటి జోగి జోగి రాసుకుంటే బూడిద అవుతుందని చెప్పేసి, సంథింగ్ లైక్ దట్. మూర్తి గారు, ఐ హోప్ మై తెలుగు ఇస్ నాట్ స్క్రూడ్ అప్ దేర్. సో ఇంకేముండదు, కరెక్ట్ గానే చెప్పాను కదా. సో అలా, so when you're talking about inspections and all of these things, right, wherever there is that subjectivity, it becomes all the more important for the people involved to be intelligent. Outcomes would be very poor. Kind of like how they are building those flyovers in Hyderabad which keep falling down. I'm sure the guy has no clue about civil engineering and all that. And those are the people who build those bridges, and we pay the price. And say, yeah. Okay. 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 Corruption. Correct. Correct. Hey, students, I didn't say that. Okay. Yeah, that is true. Corruption is everywhere, Andy. I don't know if I shared this story talking about corruption. I once lost $1 million contract at a company here, and the manager who wanted me to give a proposal is a young guy related to the great N.T. Ramarao. Okay. And then he said, Pratap, you know why you didn't get the project? I said, tell me why. Then he said, the company which got the project donated $100,000 from VP on down. Obviously, I didn't get the project, right? So those kinds of things happen all over the place. I actually asked one friend who used to represent one of the top IT companies in India. So I asked him, tell me the secret sauce. How do you get all these nice projects for this company in India? Then he said, Pratap, all these guys have, we have mastered the art. We infiltrated US IT with our Indian techniques. So that's where the politics and the corruption come into play, right? So, okay. Now, what are the advantages of here? Are you getting static? 1 second. I'm getting severe static. Hold on a second. Okay, thank you. Somebody has to mute. Vijayanagaram, can you mute yourself? Okay. For some reason, I'm not able to mute Vijayanagaram. If they can mute themselves, it will be great. Okay, Vijayanagram, you dial back in. Okay, I think the static is gone. Vijayanagram, I had to expel Vijayanagram because I was not able to mute them. So they'll hopefully dial back in. Okay, so what are the advantages of inspections? Obviously, right, we are able to catch the errors before they are implemented. The later you catch the error in the software life cycle, it costs you 10 times more. Let's say to fix something costs $10 in analysis stage, it is going to cost you $100 to fix the same thing in design stage, and $1,000 if you catch that error in implementation. So the advantage of inspections is that you are able to basically catch them upfront, the errors upfront. Okay. Okay. Are you getting static or are you able to hear me? And yes, somebody is having a. Okay, so she. Okay, let's see. Okay, I'm muting Chakravarti Garu. Yeah. Okay, I think noise must have gone now. Okay, so that's so much for inspections. We beat it to death. Let me move on to other topics here. Okay. One of the things to note here is inspections and testing are complementary and not opposing modification, because you don't have the code to test, obviously you're doing the inspection, right? So they are like complement. They are part of the continuum which goes from all the way from requirements to deployment. Okay. Notice one thing here, inspections cannot check non-functional characteristics like performance, usability, and so on, right? The reason is there is no, how do you check the performance? Unless you are a theoretician, right? There are ways of checking the performance of code. Once you write the code, if I know your algorithm, I can tell what the performance would be for that. Okay, if you look at the reference books of Donald Knuth, who wrote the big reference book on data structures and algorithms. So if you read that, you will understand how to analyze the performance without really actual execution. But for normal human beings who do not do all of those things, the way we test the performance is by running the code. Okay. Okay. So it's a circular loop, as you can see here. You are going to write the test cases, right? When you write the test cases, you need to have the test data. Okay. And then you also need to use that data, run the program with the test data, and then document the results, right? And when you document the results, you're comparing the results to the test cases. So what is the test case? Remember, I gave you an example of balance, right? Updating balance in an ATM machine. The test case, I said, user deposits $300. The output should be $400. That is the test case. Okay. So I'm going to run the program. I feed the test data 100 and 300. I look at the results and compare the results to my test case. If they are matching, that means the test is correct. If they're not matching, then you alert the developer. Okay. Now there are different phases of testing. When you have the development team, they do their own testing. Let's say there's a development team of 10 programmers. Okay. So each of the programmers So the individual programmer who's testing his own code, typically we call that as unit testing. Okay. Remember, I gave the example of 10 programmers. Each one writes his own code and they test their own code. This is unit testing. Now, all the code, the 10 programmers should be working together. So there's a level of testing there where you are combining the work of all the programmers and doing some testing. Okay, I'm hoping that you are following me there. That is typically called system testing. Here, if I were to create there are, so I'm taking an example of, let's say, I'll call it 7 programmers. Going back to 7 programmers working on ATM functionality. Okay. Now each programmer works on his piece of code. Okay. Remember our layered architecture model, right? Let's say one program is working on the UI part. One or two programmers are working the UI part, right? Other programmer working on business logic. And then other programmer working on the database, on the backend database, right? Instead of saying one programmer, I'll say one team, or one, let's call it one programmer. Okay, let's say 3, right? Now, so the UI guy is writing the code responsible for what the presentation layer, right? So they have to they have to write the code to display username password to begin with, right? And then once the username password is given, then they have to display the screen, what transaction you want to perform, right? Withdrawal, deposit, balance inquiry, right? So they'll write code to display that screen and so on. And they have to test their code. The start button, is it showing the login screen or not? So they'll be checking only that functionality and nothing else. That is unit testing. Got it? Now, once that unit testing happens, when the user is going to select the functionality like withdrawal, then the business logic guy has to ensure that if they're withdrawing $100, there's enough money in the bank for the user to withdraw $100 to begin with, right? I may have negative bank balance and I try to withdraw $100. I should not get $100. The system should tell me, hey, you do not have enough money. Logic guy. Okay. Now the database guy, he would be testing, hey, have all the database tables related to this user been updated correctly after the transaction is done. Okay, so each one of them is responsible for testing their piece of the code. At the end, all of this code should work end to end. We call it end-to-end testing. That is nothing but the overall system testing. Let me pause here. Anyone has questions? By the way, I'm simplifying this for you. I'm not getting into too much here. Who wants to talk? చెప్పండి మూర్తి గారు.
100 కావాలి.
I unmuted you. You were about to say something. Okay. He's not saying anything. Okay, good. Okay. So you have unit testing, component testing, system testing. Depending on how big the team is, the levels of abstraction varies, right? In the case of the JNTUK Kakinada information system, the component testing would comprise of many subsystems. They will have the student registration system, they will have a faculty system, they will have the registrar. So each of them, you have to perform the testing. So they could be called component testing or subsystem testing. Now, end to end, all these components should work together. So that is called the systems testing. Easy to follow. Okay. Now, since you all understand programming, object-oriented programming, you can see here when we define classes, we have to test all the operations in a class, right? And then looking at the data, right? And then looking at the dynamic behavior of the object, you want to make sure that all the states of the object are reachable. Imagine I gave you recall I gave you the example of vending machine, right? In a vending machine, there are multiple states. Initial state is the rest. Tirumala garu, can you mute yourself? I'm not able to mute you.
So, I'm muted. Low bandwidth, sir.
Okay, no problem, no problem. So I'll continue to talk. If people are not able to hear me, put it in chat and I'll figure out something. So in the case of classes then, you should be checking for the testing the methods of all the classes, okay? And you have to make sure that the objects of that class do go through all the possible states. That means you're modeling the dynamic behavior. So you have to test the dynamic behavior as well. That's what this slide is saying. Okay. I'll skip this example because we covered the Okay, let me jump ahead to some of the slides here. Okay, a lot of theory. I'm skipping some of the theory here. And I told you testing happens in multiple layers, so I'm skipping some of these things. This is an important one. Let's look at slide 39 here. Interface errors. Where do you think most of the errors happen? They happen at the interfaces between system and the other subsystem, right? Why does it happen? Because of this significant factor, interface misunderstanding. Can you imagine? Here is a scenario for you to bring out the point. Let me create a new slide here. Okay, sticking to our ATM example here again. The presentation guy, this is the presentation layer programmer, okay? Here, he is asking, okay? So in his code, he says once the username and password is authenticated, I'm writing pseudo. Send this information to business logic code, right? So in the case of business logic code, the input that the input parameters that it is expecting, whatever the class it has, it is expecting username, password. Okay. Somebody is really banging at their speaker. Okay. So if they are expecting username and password, and what is passed by the presentation layer to this business logic code, then the interface is matching, correct? Now imagine somehow if I change this one here, is authenticated. That means what is the assumption that I'm making here? The assumption that I'm making here is the presentation layer has authenticated the user, right? That's what this says, right? Got it? But imagine for a change, or for just to argue the point here, if I say once the username and password is entered, information to business logic code for authentication. Okay. Did you see the difference? What I just did here? In the first case scenario, I said the presentation layer is authenticating and then sending the username password. But imagine if I change it slightly, say the presentation layer, the user is entering name, password, and the CAPTCHA. Remember the CAPTCHA symbol, right? That's a security mechanism. It says type in the letters that you see, right? And the business logic code, if the input parameters, it's still expecting only username, password. There is, right? Because the presentation layer is sending three things, whereas the business logic code is expecting 2 parameters. So when the presentation layer is going to send 3 values, can the business logic code take those 3 values? It cannot, because it's expecting 3 values. It is only going to take only 2 values, right? So that is what we mean by interface error. So whenever when you are working in a multi team structure where different groups of people are working on more time is interfaces. You have to make sure that the interfaces are defined correctly. Okay. Second thing, timing errors. Timing errors are very subtle errors. They are not logic errors, right? It is about performance, right? Sometimes when you make a database call, I'm sure most of you have seen it, the system simply hangs. It shows you in a busy loop and it doesn't come out, right? That is one kind of timing error. It's actually an infinite loop. Actually, it's much worse than timing error. And then the second thing is the caller. Now, if the response doesn't come in 2 seconds, it times out. It cancels the call. Okay, that could happen too in programs, right? Whenever you are programming, as you get more advanced into these types of programming things, you time your code. Okay, so there could be some time related errors too that can creep in. Okay. Now, how do you test these interfaces? As it says here, you design your test so that the parameters to a called procedure. Okay. What programming tricks here? Okay. Null pointers, right? Always pointer parameters with null pointers. Anyone remembers null pointers from your programming? Any student remembers? What does null pointer mean? I can unmute Aditya. I can unmute GEC. What are null pointers? See, what null pointers means, it's an unallocated pointer, right? Remember, whenever you are using pointers in C or C++ or a pointer cannot be used unless it has been assigned to a known storage value, right? If it is pointing at nothing, it's a null pointer. So very famous programming errors are null pointer exceptions if you're a C or C++ programmer. So whenever you have pointers, you test for null pointers. That's what it is saying. I won't spend too much time on that. If you don't understand null pointers, what it basically means is test it to its limits. That's basically called stress testing, right? Remember, I gave you an example of how to try to fail a username password by inputting long strings. That is what I'm doing there. Okay. Now, whenever you have shared memory systems or you're building concurrent designs, I don't know if you have taken a class on operating systems. We learned the concept of semaphores in operating systems. Let me put the word here. You know what semaphores are, right? P and V. If I remember it, P semaphore, V semaphore, and all this. So what happens basically is you are when you're entering a code which is shared, you want to allow only one process to enter that code. That way the results don't get overwritten. So that is what it says. When you have a shared memory system, you vary the order in which these are tested to make sure the behavior is still consistent with what you're expecting. So system testing, I told you end-to-end testing. Okay. In the process of doing that, you are testing the interface interactions. Okay, that all subsystems are working okay. The messages between the subsystems are flowing as they're supposed to flow, right? And then the overall behavior of the system is what you're testing. Okay, my apologies again, I'm getting a lot of static. Let me mute. Okay, that's gone. Good. I think Vijayanagaram internet connection is there still. Okay, so that is system project. I'll make you do all of these things anyway. Even though we don't have too much time, you'll still be doing that. Okay. I think I will stop here for now. Let me see. Okay, let me cover this chapter, this couple of slides, and then we'll call it for the day. So now what happened is we moved to Agile, right? Remember I told you testing is now integrated into DevOps. Okay. So you're doing testing and code development interleaving. You write some code, you test. What you're doing is the following. Number one, the test team is not separate from the development team. They're all one big integrated team. You're developing your code incrementally, meaning small behavior, one at a time. You test that. Once it works, then you go to the next increment. If you recall, in the beginning when we talked about agile methods, we talked about this, right? We have each of these agile cycles as 2 to 3 week cycles. Okay. So in those 2 to 3 week cycles, the focus would be on release of a development. There's a picture that shows here, right? For every functionality, run the test, okay? And if the test fails, if it fails, then you go back and fix those bugs, right? Now, once it passes, you add new functionality. So that means you keep adding functionality in increments. That's why it's called incremental development. A very classic way of doing agile development methodology. Okay. In essence, talking about what is a minimal viable product. Remember, I gave you an example of a minimal viable product. What is that 2 week increments? Like, for example, for your project, I'm glad I'm seeing the video again for all of you. For your project, we will have time to do I would say 3 to 4 weeks. After the midterm, the entire focus would be on the project for the next 3 weeks, 3 or 4 weeks. And I'll make you do two agile cycles. Move on to the next functionality and so on. Okay. Now, what are the benefits of that? Benefits are you are able to basically do the testing upfront. That means you'll remove the bugs upfront, right? And all code has been tested as it goes along. And all the test cases that you develop as you go along would form your baseline set for regression testing. And what is regression testing? Regression testing is whenever you are adding some new functionality, you have to make sure to ensure that all the previous functionality works, you rerun all the tests that have been developed for that system. That is what regression testing is. So since you are writing code, testing software or testing code right from the beginning, you'll have lots of test cases for which code has been written. So you run all those tests every single time. Debugging is simplified because you're writing the code incrementally. If something fails, chances are it is failing in the new code that you have written. So you can quickly locate the source. Okay. See, that's where the definition of regression testing is, right? Testing to make sure the system changes have not broken previously working code. That happens all the time, right? My own small development team, whenever they're writing something else breaks. In the rush of getting these apps and code to the marketplace sooner, sometimes we are compromising on some of these things. And as a result, after we release our software, some user points out a bug and we have to go fix that. So in summary, what is testing? Each developer does his own unit testing for a small piece of code. Then multiple programmers come together to test their own components. And then after all the components are tested and all of the development happened, then we'll do what is known as an end-to-end testing. In the case of ATM machine, all the way from getting the username password to completing the transaction that the user selects. That is end-to-end testing to make sure the system works end-to-end. You'll all get a nice job. In the industry, you will get used to what is known as releases, product releases, right? Every product has a release life cycle. Now, when you're releasing a product, what it basically says is, hey, I'm releasing this product 3 months from now. It is going to have the following set of features, right? So all the things that go as part of one release have to be tested. Okay. And who is doing the testing? It is done by a release testing team. Okay. Whether you call it QA or whether you call it release testing, like is that still true in today's development DevOps world? Probably not. Okay. Most of the release testing is also done by the DevOps team. But if you are doing a traditional lifecycle model, there'll be a dedicated release testing team which should be doing the testing, but except that testing is known as black box testing. Okay. So what does black box testing mean? They're only giving input values and observing the output values. They don't get into the code. For them, your entire system is nothing but a black box. But I hope you are able to hear. Okay. So, when the developers are testing, they are actually testing the code, right? They are inputting some values to the code procedures or methods, and then they are looking at the output of that method or procedure. In contrast to that, the release testing team doesn't know what the various modules of your system are. For them, the entire system is a big black box. And then they look for output values. If they match, then they sign off. unmuted everyone except Vijayanagaram, and the system is not allowing me to mute Vijayanagaram. Okay, let's hold on a second. Okay, better? No. Okay. Can you hear me now? This testing is black box testing. What black box testing means is the guys who are working on this team, they have no clue what code you have written. They know what should be the inputs to the system, what should be the outputs. They are not going to look at your code. They don't understand what the main components of your system are. They have no idea about those things. All they say is, hey, here is the input. It's kind of like, let's say if there's a TV manufacturer, and then I'm a release testing team member, I'm looking at the TV, I'm saying, where is the on button? If I press the on button, does the TV come on, right? If there's a separate off button, I'll press the I look at the interface, right? I say, okay, where is the fast forward button? Where is the rewind button? So I'm just testing those at the interface layer. That's all I'm doing. So that is the release testing, folks. Now, typically when you do release testing, I actually have some, I don't know if I can show you that here, but next time I'll show you some examples of release notes. We actually did a release just yesterday. So let me see if I can share that screen with you. Give me a second. If I have that here somewhere. I'm looking for a document still. You have to wait. You find what you're looking for. Okay, I can't find my release notes. Next time I'll show it to you. It'll take a I'm going to summarize it. I think I'm sharing my screen, right? So as we discussed, testing can only show the errors. It can demonstrate that there are no remaining faults. Remember, it's really an undecidable problem in mathematical terminology. You can never say that it has no errors. Okay. Testing is a testing team which would test your release from a black box testing viewpoint. Okay. Now, from a development team viewpoint, each programmer does his own unit testing. Then multiple components are tested together, and then all the components are brought together and tested end to end. So that's why we use the terms unit testing, component testing, and system testing. And then finally, release testing. Okay. The name of the game is the software, right? Now, most of this testing that we talked about is functional testing. In contrast to functional testing, you have other types of testing. The other types of testing include, for example, security testing. usability testing, which is a very, very significant aspect now, right? It's called the UI UX. UX stands for usability, right? Where what is the user experience like? Okay. Most of these UX guys, they say, hey, these labels are small, they are not aligned correctly. It's not a user-friendly text. You did not provide help text here. These are the type of things that they test for. Okay. Uh, Always be nice to the usability testing guys. A piece of stakeholder is really the UI. So that's why this UI UX guys are very important to your team. These days they go by different titles. They are called like the digital gurus. Everything is now digital. So they don't call themselves as usability testing people. They call themselves as digital transformation engineer or digital experience engineers. So that's just a nice big buzzword to say that they test for usability. Okay, so those are other aspects of testing too. When you execute your project, you will get experience on all these types of testing. You must be we'll shorten it into two weeks, and then we'll do a second cycle also in the remaining week to 10 days. Okay, questions, comments. Sorry, my apologies for the static today. It did not come on my side, sure I can tell you. Questions, comments, you have some time. I'll be happy to answer questions related to exam, which is coming up Monday. So what we'll be doing, let me see the participants list here. I'll unmute a few of you in case you want to talk. So Sunday night, my time, this is the next class. All of you and your professors can monitor you if they want to. My tests have no time limit. You should be able to do it in 2 hours, but if you need extra time, I will leave it to the professors there to give you that extra time where you can either do it in the class or go somewhere and do it. I know that in institutions in India, there is some, even here actually, there is some concern about cheating and so on. I will let your faculty members. I call it an honor system, right? I have enough checks and balances to verify what you have written. Just because you have an answer does not mean you'll get your 100 points. I reserve the right to question you on your exam paper to verify and validate. Remember, we talked about verification and validation. So I do my own V and V. And if you fail to answer my questions, even though your exam paper shows everything correct, I reserve the right to still give a 0. That's how I do my verification validation. Okay. Any questions on the upcoming exam? By tomorrow. Okay. So to get their feedback as well, because I do not know how testing is done in India now. I will follow my rules here and then send it to them, get their feedback, modify the test paper, and then Sunday you will be doing it. Okay. Aditya, G, any questions from faculty members? Chakravarti garu, do you have any questions?
No, sir, no.
Okay, great. I'm done.